In this video, we're going to be discussing classes and inheritance in Python. Class inheritance allows for a class to inherit attributes and methods from one or more other classes. It also allows for the derived class, that is, the class that's actually inheriting from the others, to override any names that it inherits. So let's take a look at an example. We're going to create a class that's going to serve as our base class. And this means that this class will be the parent from which our other classes will derive. So just as we did before, I'm going to write class, and we'll just call this class our base class. Note that for the name of this, I am following PEP8's guideline for class naming. That is, the first character of each word is uppercase, and all other characters are lowercase. However, I will point out that naming a class base class is not generally a good idea. The name should actually give some indication of the purpose of this class. However, for this example, we're going to stick with base class. And then in the body of this class, I'm simply going to define a class member x with the value 42. Now for our child class or our derived class, we're going to declare it just as we did the base class with the class keyword followed by the name, derived class. Again, the name of the class should give some indication of what this class is used for. Now, to show that this derived class inherits from our base class, we're going to use parentheses here and then write the name base class. And so just as you would pass an argument to a function, we're effectively passing the name of the class to be inherited from as an argument here. Then in the body of our derived class, we're going to define a method f, which is simply going to print the value of x, which is inherited from base class. So at this point, our derived class inherits all of the members from base class, meaning that the derived class has access to the class variable x. And so if we were to create an instance of our derived class and then call the method f, we'll see that the value of x is output. Likewise, we can actually print the class variable directly using derived class, and we'll see that value here as well. Now, if a name that appears in a base class is bound in a derived class as well, then the base class's name will be hidden. That is, the derived class will actually override or mask that name. So to see this, we're actually going to copy and paste the previous example. And we're going to modify our derived class by adding an init method. And this init method is simply going to define an instance variable x, which of course is the same name as the class variable x from base class. And it's going to bind the value 96 to it. So now when we create an instance of the derived class, the instance variable x will hide the class variable of the base class, and the method f will print the local x instead. Now the base class x is still accessible, and so in the last line you can see that if we print derived class.x, it still has the original value. Alternatively, we could have written base class.x here and received the same value as well. Now method names can also be hidden. So if we write a simple init method in the base class that prints base init, and then for this example, we're going to remove everything from derived. So I'll simply write pass here. We now see in the output that the base init function was called when we created an instance of our derived class. Now, if I were to add an init method to the derived class, we now see that only the derived init method was called, as it overrides or hides the base class init method. Now we can still call the base class init if we want, but we'll need to explicitly call it from the derived init using the function super. So I'm going to paste the example again, and now in the init method, I'm going to write super dot init. The super function helps us to access methods that have been overridden in a class. So for more information on super and how to use it, I've given you links to a guide to using super here, as well as a link to the documentation on super here. But if we run this block now, we see that both base init and the derived init methods are called. Now Python supports multiple inheritance as well. And this means that a derived class can inherit from more than one base class. So for example, let's say we have the following three classes, A base class, B base class, and C base class, from which we wish to inherit on our derived class here. So to do so, in parentheses, instead of listing a single base class, we'll actually list several base classes separated by commas. And so derived class here will actually inherit all the members of A base class, B base class, and C base class. However, as you might have guessed, now things become a bit more complicated. especially when it comes to name resolution. So in a derived class, if you use a name, in order to figure out which object that name refers, Python will first search the derived class for a local instance of that name. And if it doesn't find it, it's then going to perform a depth-first search from left to right in this list of base classes. So we're going to modify this example a bit here in the next block to show you how that works. So I'm going to paste some code here, and I've shortened the names of the classes to make this a little bit easier to describe. But we have a class AA, which has a member X. We have a class A, which inherits from AA, and then it has an empty class body. Classes B and C are similar to AA in that they also define a member X. Now, our derived class will inherit from both A, B, and C. And so A, if you recall here, inherits from AA. B and C do not inherit from any other classes. In our derived class, we have a member function f, which simply prints x. And so now the question is, which x does this refer to? And if we run the block, we see that it outputs AA, meaning that this x refers to the x defined here in the base class AA. Now, why is that? The name x did not appear in derived class. And so a depth-first search was performed, starting with A and then going to B and C. And the search stops as soon as it finds a name matching X. So in this case, it went to A, and it saw that there was no name X here. And because it's depth first here, it checks A's base class, which is AA here. And it did find that X was present, and so this value was used when the method f printed X here. If the name X had not been found in AA, the search would have continued on with classes B and C in that order. Now, when it comes to inheritance, this is really just the tip of the iceberg here. And so I've given you some links at the bottom for method resolution order, super, and then of course the guide to using super again, to help you get started on working with and learning more about inheritance. Now, in this last section here in the notebook, I've given you two built-in helper functions that can be helpful when using inheritance. The first is isInstance. This function returns true if the passed object is an instance of the type passed here, or if it's an instance of a type derived from this type here. And so if you recall, object here was an instance of the derived class, which inherited from base class. And so this function returns true. The second function is subclass. Instead of dealing with instances of objects, this deals directly on the types. And so it returns true if the type passed as a first argument is a subclass of the type passed as a second argument. So in this case, this returns true since we know that derived class inherits directly from base class. This would also return true if derived class inherited from another class, which then inherited from base class.